Okay, so welcome to tonight's webinar. Tonight's webinar is on analysing exam papers in mathematics. So we're going to use the example of AQA Maths and we're going to use the module Core 1. Okay, so Core 1 is what everyone will have done or will be studying. Okay, so everyone will understand the topics in Core 1. So that's why I've decided to pick Core 1. Now the strategy I'm going to show you is, it's quite accurate. It's not 100% perfect, but it gives you a good indication of what topics will be expected to come up this year and roughly how many marks they will be worth. Right, we're going to do this by looking at previous papers and creating a spreadsheet. Right, so I've gone through this. Hopefully you can all hear me now. If you're seeing this and you can't hear me talking, then type in no sound. But I think everyone can hear me. Okay, so how does the webinar work? So you've got the questions box or chat box, and you're going to get interactive polls. Okay, so actually I might as well give you a poll question right now. So let's start off with a poll question. So first of all, I just want to know what level you are currently studying. So you don't need to type anything in, you just need to click on there. Okay, so excellent. So that's everyone's voted there. So I can just show you that. So a majority of you are AS level students, but we've got about a quarter of you are A2 students. Okay, that's fine. One of the questions coming through, will you send us a copy of this webinar? Yes, at the end of the webinar, you'll be asked to do a survey and there'll be a question on there. Would you like to receive a recording of this webinar? Just choose yes, and then I will email that across to you probably tomorrow. All right, and while we're on polls, I can just give you another question before we get started. So what grade are you hoping to achieve at the end of this year? Okay, this is good. Wait for one more person to vote. Give you 10 seconds. Right, I'm liking the results at the moment. Perfect. Right, I'll share that with you actually. That's pretty good. So about almost 3/4 of you are wanting an A or an A star, and about a quarter of you are hoping to get a B. That's perfectly fine. Right, so we've done that. Right, so I said this will work for A-level maths. It works for all maths modules, and you can do this as a simplified way, or you can do it on a detailed way. Right, so I'm going to run by both methods. Right, so if we analyze the Core 1 AQA syllabus, there's a number of topics that we can sort of break it down. So if we try and break it down to sort of about 8 to 10 topics. So I did that earlier, and I came up with these topics: basic algebra, polynomials, quadratics and discriminant, simultaneous equations, coordinate geometry, circles, differentiation and integration. So 8 topics. Okay, and what we're going to do is we're going to put this into a spreadsheet. Okay, so I've kind of done this already to save some time. If you want, I can send this to you, but it's not difficult to make. So topics are on the first column, in column A. So I'll put the 8 topics there, and then I've just put down a bunch of the most recent exam papers. So June 10, Jan 11, June 11, Jan 12. Some of you that are doing the AS, you may not realise, but there used to be January exams a couple of years back, only just stopped a few years ago. Right, so we've got June, so you used to have 2 exams per year, but now we only get 1, so June 13, June 14. Right, and then we can sort of predict June 15 by the end of that. I'm not going to fill out the whole thing, I'll do about 2, all right, maybe 3. So these are the main topics. Now, you won't always get all of the topics, so I've left a few rows blank so we can add in a few more topics if we need to. So this is the simplified version, and then there's also a detailed version. So the detailed version, I've sort of split it up into smaller topics. Okay, so instead of just basic algebra and things like that, I've got factor remainder theorem, then I've got long division, I've got linear simultaneous equations, quadratic simultaneous equations, I've got optimization, second derivatives, stationary points, and I'll have normal differentiation as well in there. Okay, we'll probably add in a few more. We're going to stick to this for the time being. So first thing we need is a bunch of exam papers. So we will start with June 2010. Right, now these can be downloaded off the AQA website, or if you're studying Edexcel or OCR, you can download them off the websites. The only one you might not be able to get is the 2014 papers, but if you do a quick Google search, you can find it. Right, so this is the AQA Core 1 paper from June 2010. So this one is just the simplified version, so we're just looking at this first question. So just type in what topic you think this would come under. So out of these topics, okay, so I'll put it there for a bit more time. Alright, so a couple of you are typing in the right answer. So coordinate geometry. Now remember, this is the simplified version, so I'm not going to go into detail and break it down exactly, but this is coordinate geometry and we're just going to add up the marks. Okay, so we're just going to add up the marks. So we have 2, 2, 4 and 3, so that's 11 marks on coordinate geometry. Okay, so coordinate geometry, 11 marks. And what I'm going to do, so I'm just going to stick in a formula here for the sum. Of that. So hopefully that will get to 75 by the end of it. Right, next we have surds and more surds, so rationalizing the denominator and just manipulating surds. So let's see on our table, where should that go? Now I could put in basic algebra, but surds is quite an important topic, so I might just make that a topic on surds. Rather than having rationalized the denominator separately, we'll just call it surds, and that's going to be 6 marks on surds. Okay, now it won't look like much to start off with, but once you've got a few papers, so I'm just going to go through this a little bit quickly, so I'm not going to ask you for every single one. Factor theorem, so that would come under base polynomial. Yeah, I'll put it under polynomials there. So we've got 2, 3, 2, so that's 7 marks. Right, and then since this is a simplified version, I'm probably going to put this all under polynomials. So this is 12 marks. It's really up to you how detailed you want to go into. Right, so if you want to go into lots of detail, that is perfectly fine. It's probably going to be more accurate for you. Okay, so question number 4. Alright, so this is on integration. However, it says find the gradient, so it's also mentioning differentiation. So I'm going to go with 7 marks on integration and 5 marks on differentiation. 7 marks and 5 marks. If you're not sure what I'm doing, just type something in, but hopefully you can all follow what's going on. Circles. So the equation of a circle, so 3, 1, 3, so that's 7, add 4 is 11. 11 marks on circles. Okay, so this one is optimization, which comes under differentiation out of our topics here. So that's going to be 5 and 6, 11 marks. So 11 more marks onto this. Alright, so we got quadratics, discriminants, completing the square, that should come under, so you've got quadratics and discriminants there. So let's put it all under that, so that's 12 marks. Okay, and that's added up to 75, and I haven't had to use the miscellaneous row. Okay, so that's that paper. Hopefully there's no more questions. Good. Let's look at the next paper then. So this is June 11. Oh no, there should be a Jan 11. Let's try and find that. Jan 11. Okay, so that's our first column complete. Now we're going to look at the second column, and you'll start to see some patterns. Probably more likely to see them after 3, but let's quickly do this one. Right, find dy by dx, find d2y by dx. So this is differentiation, that's 10 marks. Copy this formula. Okay, we've got surds, 5 marks. And this is coordinate geometry, 11 marks. So you've got surds, 5 marks. Coordinate geometry, 11 marks. Right, even though we've only done 2 papers, you can start to see some patterns already. Okay, this looks like integration. Let's just make sure there's no differentiation on this. Find the gradient, so there is a bit of differentiation there. So let's find the gradient, and then it says find the equation of a curve. So if we were doing this in detail, I would split this into differentiation 3 marks, coordinate geometry 2 marks, and then integration 7. Right, but this is a simplified version, so I'm going to call that all under differentiation. So that's 5 and 7 on integration. So 5 on there, so that makes it 15, and 7 on there. Sketch the curve with that equation, so that could come under basic algebra, and this would be polynomials. So that's 2, 4, 6, 9. 9 on polynomials, and I could put that on basic algebra 4. So 4 there, sorry, 9 there, and 4 there. Right, if you look at the gaps, we can probably predict that the remaining questions will probably include quadratics, simultaneous equations, and circles. There's another 24 marks to get. I reckon about 10 of that would be under circles, and probably some of that, probably another 10 or so, under quadratics or simultaneous equations. Let's have a look. And as predicted, circles. So how many marks is this? That's 5, 8, 9, 13. Now there's a further 11 marks here. So let's see what the final question is on. So we've got inequalities, okay, so this would come under, let's see, would probably come under quadratics. So you've got quadratics here, sketching quadratics. This bit would be the discriminant. So this is all going to go under quadratics and discriminant. So that's what, 7, 8, 9, 10, 11 marks. Right, just from that, we can get a good idea of how many marks you're going to get on each topic. I'm going to do one more because it's a simplified version. It doesn't take that long. So that was January 11. Let's look at June 11. Okay, so this one is coordinate geometry. That's 6, that's 9 marks on coordinate geometry. Surprisingly, we haven't had a simultaneous equations one, or it might just come under one of the other topics and I haven't included it. Surds, that's 8 marks on surds, so this was a much bigger question on surds. Right, so dv by dt, so differentiation, that's going to be 5 and 6, 11 marks. So usually there's 2 questions on differentiation, so that's the 11 mark, and there's probably going to be a smaller one later on, I predict. I may be wrong. So this looks like quadratics, vertex symmetry, yeah. Okay, so this would go under quadratics, so that's, we've got 9, 12. Polynomials here, so that's 8. So we've got integration, find the area, so that's 8 marks on integration. Alright, inequalities, 6 marks. I haven't really put a section for inequalities. Probably put it under basic algebra, or I could put it under miscellaneous. When we do the detailed one, we'll have an inequalities section. Right, circles. How many marks have we got left? 13, that's probably it. Yep, 13 marks on circles. Right, so I'm just going to do that one for the simple one. Now, although it shows that simultaneous equations hasn't come up, it probably has, but we've probably included it in something else. So now we're just going to total these up. And we're going to work out the averages. I'm just going to copy the formula now. Okay, so we can now sort of predict, this should add up to almost 75. That's because we've rounded. Yeah. Alright, so we can predict that in our exam there should be about 5 marks on basic algebra. There should be about almost 10 marks on polynomials, so it's quite a big topic. Quadratics and discriminant is a massive topic, 12 marks on average. Coordinate geometry, you're looking at about 10 marks on that. Circles, you're looking at 12 marks, that's quite a big topic for you guys. Differentiation, so 14 on average, sometimes they come up once, sometimes they come up twice, but they definitely come up. Integration has come up on every single paper so far, and surds has come up on every single paper, averaging 6 marks. So as you do more papers, your results become more average. So if I was now to sort of predict these ones, I could probably use the average ones, and I could say, oh, there's probably going to be 5 marks on this, got 10 marks there, 12 marks there, 10 there, 12, 14, 7, and 6. Obviously, the more papers you analyze, the better your prediction. Right, does anyone have any questions on that so far? That's the simplified version. If you have any questions on the simplified version, please let me know. Right, that's fine, that's good. So now I'm going to go through the more detailed version. So we go back to the slides. So I've sort of picked these topics, but we're probably going to add more topics. Now this will take a lot longer to do, right? That one that I did, you're probably looking at about 5 minutes per paper, so that whole thing would take you less than an hour to do for core 1. And then if you did core 2, core 3, core 4, you know, you're looking at a couple of hours work and you've got it all. This detailed one, right, I put a lot more topics. I'm probably going to need a few more. Okay, actually I'll probably just add them as I need them. Okay, let's get rid of that. Alright, so let's add the formulas in. Alright, so we're going to go back to June 2010. But this time it's going to take a little bit longer because we're going to break it down. So we're probably only going to look at analysing 2 papers this time around, just because of the amount of time this one will take. Alright, so now you can break this down into whatever you want. I mean, if you wanted to be really good about this, you can split it down into every single aspect of coordinate geometry. You could have gradients, you can have equation of a line, you can have midpoints. What have I done so far from equations? Coordinate geometry. I've got circle geometry. I've got basic circles. I don't think I've even got coordinate geometry. So let's do the equation of the line, because that's quite an important one. And let's put other coordinate geometry. Right? There's no need for me to go to every single topic. I just want to explain what you need to do. Right? If I try and do this in detail, it'll probably take me about an hour to do each paper. But I don't think you want to listen to me for a whole hour. So finding the equation, we've got 2 marks here. And finding another equation, we've got 4 marks here. So 6 marks on finding the equation. And then other coordinate geometry would be the remaining 5 marks. So that's question 1. Question 2. So we've got, I think I've separated surds. Yeah, so we've got surds and we've got rationalizing the denominator. So manipulating surds would be the 2 marks. And then here we are rationalizing the denominator, 4 marks. So that's 2 and 4. Okay, polynomials. So factor and remainder theorem, that are long division. So factor theorem, so that's 2 marks. Remainder theorem, 2 marks, that's 4. Express this as 3 linear factors. I'm going to put that under long division. There are other ways to do that, but we'll put that under long division. Verify this. Let me put 3 marks on long division. So verify that p of -1 is less than p of 0. I'm going to put that under factor theorem. I'm going to add it into there. Right, I could put in miscellaneous, but all you need to do is you need to substitute -1 into there and 0 into there. It's kind of what you do for the remainder theorem. So I'm going to add that one into that. So make that into 5. And sketch the curve. Sketch the curve. I don't have a section for that. I don't want to put too many topics because I want it all to fit on the screen. Sketching is 4 marks. Alright, so we've got integration, and then find the area shaded by the curve and the axes. Curve and line y equals 9. So I made area under graph and I did basic integration. You've got to use your own judgment here. Should I put 7 marks under area under the curve? So should I go straight, should I do that? Or Should I do 5 marks for basic integration and then 2 marks? Should I do 5 there and 2 there? What do you guys think? What would you prefer? 5-2 or 7-0? So I got it wrong way around. No, that should be 2 and that should be 5. Basic integration was 5. Okay? Yeah, so the first part is basic integration. Okay, looks like everyone wants to do 2 and 5. So this one I put under basic integration, and then this one is the area under the curve. But technically this one is finding the area under the curve between 2 and 0, so it's working out this white space. Okay, again that's up to you, just make sure you're consistent throughout. Part B, find the gradient, hence find the equation of the tangent. So the gradient, that would come under dy by dx, so differentiation 4 marks, and then I could add that to the equation of a line. So 4 marks on differentiation and then 1 mark on, so differentiation, do I even have that? No, I don't. So 4 marks on differentiation and 1 mark on the equation of a line, making that into a 7. So we've got circles. I think I made 2 sections. So basic circles and circle geometry. So basic circles is things like finding the center and finding the radius. So that would be find the equation. So that would be that, and probably include that as well. So verify that it lies on the circle. So 4 marks on basic circles. And then circle geometry, I think that would be the rest of it, or find the equation of the normal. So again, I could put this into the equation of a line. Okay, and then the midpoint. So I think I might do that. So I'm going to put this under equation of a line. And I'm going to put this under circle geometry. So 3 for the equation, 4 for circle geometry. 4 there. And 3 more on this. So up to 52. Right, so this is an optimization question. So 3 marks to start off with, followed by, hence show that, so 2 marks. So I'd say all of that is the optimization part. So 5 there. Find dv by dx. So this is just basic differentiation. So I'm going to add it onto that. So add 2 onto there. Stationary points, so I've got that here, so 2 marks there. Okay, second differentials, 2 marks. Right, next one. So this is completing the square and explain why there are no real roots. So that must be the discriminant. No, completing the square. Do I have anything for that? No. So I'm going to call this quadratics. And we're going to call it 4 marks for quadratics. And then this one looks like the discriminant. So it has real roots, discriminants. And then, so 4 marks for the discriminants. And then the final 4 marks, find the possible values of k. You're solving this inequality. So that's going to go under inequalities. So I need the discriminants, and then I need one for inequalities. Inequalities I have. Discriminants. Of course, if you don't want to make a new topic for a new row for everything, you can just put it under miscellaneous. Okay, that's my first paper done. I'm just going to do one more very quickly. January 11th. Find dy by dx, 3 marks. Stationary point, 3 marks. d2y by dx, 3 marks. And minimum point. So differentiate, stationary point. Differentiation, 3 marks. Stationary point, 3 marks. Second derivative was 3. And the last bit is maximum, minimum. Probably put that under second derivatives as well, making that 4. Third, so we've got 1 mark and 4 marks for rationalizing. So how many marks do you think you get on rationalizing the denominator each paper? Just from the analysis of these two papers. You can predict that there should be 4 marks on rationalizing the denominator coming up. So that's 4 out of 75. So 4 marks out of 75. So 5% of your paper is on that. So 5% of your revision time could be spent on rationalizing the denominator, but it's not that hard of a topic, so you wouldn't need to spend 5% of your revision time. Let's say your revision time for this is, say, 100 hours. You would not need to spend 5 hours on this topic, but it's going to be a good 4 marks, an easy 4 marks to pick up. So we've got gradients. So this mentions a line. It doesn't ask for the line equation, but I'm guessing you have to work out the equation of a line. So I'm going to put that under equation of a line. So gradients, that's going to go under coordinate geometry. That's going to go on gradient of a line. So 2, 3 so far. So 3 for that. Coordinate geometry was 2. The line with the equation that intersects that, so coordinate geometry again for part B. It has a length, so that's distance, so that's going to be coordinate geometry as well. So that's 6 marks, 6 more marks, that makes that 8. So find the gradient, so that's dy by dx, and then it says find the equation. So 3 for differentiate, 2 for equation. 2 for equation, 3 for differentiate. Making that 6. So 5b, if we're going to be consistent now, this has to go under basic integration, and then this would have to go under area under the curve. So 5 for basic, 2 for area under the curve. 5 for basic, 2 for area under the curve. It happens to match the previous paper exactly. Right, sketching curve, so 3 marks. Show that the equation that can be expressed as that. So sketching, first of all, was 3 marks. 1 mark, I'll come back to that 1 mark. Find the remainder and the factor theorem, so that's 2 and 2. So factor and remainder, so that's 4 there. Express that in that form, so that's kind of long division there. So 2 marks there. Hence show the root has only one real root, so that would be the discriminant, I'm guessing. That's equal to that. Yep, so we'll put that under discriminant, so 3 marks under discriminant. And we have 1 mark up here. Show that the equation can be expressed as that. So that's just manipulation, isn't it? Expanding out. Right, can anyone see where I could put that one? 1 mark. Which of these would you put it under? I think I know where I would put it. So the question was, show that that can be expressed as that is only a 1 marker. Which topic would you go for? Type it in. Okay, one of you's typed in, and I agree with that one. Yeah, quadratics. That's that one done. Now let's look at our gaps. So we're probably going to expect something on circles, something on optimization to come up, something on inequalities. That's just a prediction. And let's see what it is. Circles, yeah, find the equation of a circle and hence find the equation in this form. So from there to there, all you're doing is multiplying it out. So I think I can put that all with basic circles. So I'm going to call that 5 marks on basic circles. Okay, circle geometry, circle geometry. Okay, circle geometry, circle geometry. Right, one of the questions come through, what's optimization? I'll go through that in a minute. So we've got 4 marks on circles, finding the gradient. Okay, so let me put the 4 marks on circles first, circle geometry. Now, we have finding the gradient and finding the equation. So finding the equation can go under the equations, finding the gradient can go into the other coordinate geometry, so 2 and 2. So 2 marks into there makes that 10, and 2 marks into there makes that 7. Or is this the last one? Yeah. So that's quadratics, equation of this line of symmetry. I could probably put all of that under quadratics. So that would make that into 4. Show the equation, show the x-coordinates satisfy that equation. Okay, this would come under, it's just manipulating, isn't it? Just taking it over to one side. Come back to that 1 mark. Well, the 1 mark ones are the worst. Given that they intersect, show this. So given that they intersect, so that's basically using this, and you're going to use the discriminant here. So that's 3 marks, and then solve the inequality, 4 marks. So discriminant, 3 marks. So that makes that into 6, and inequalities goes 4. And there was the 1 mark here. Show that the x-coordinates of intersection satisfy that. So all you're doing is you're making that equal to that. I could put that in anywhere really. I'm just going to put in quadratics. Alright, so that's that done. Okay, so now let's just total this up. Let's just sort of prepare it for the whole thing. Right, I'm just going to divide the total by 2 for now. So if you do use these formulas, then make sure you change them afterwards. Alright, so on average we can expect 1 to 2 marks on surds, 4 marks on rationalizing the denominator, so that's quite consistent, about 4 or 5 marks on factor theorem, long division you're looking at 2 to 3 marks, area under the graph 2, basic integration 5, and you can follow it down. One of the questions, what is optimization? Optimization is a core 1 topic for AQA and a core 2 topic for Edexcel. You did AQA, so it would be in your core 1. It's basically, it usually involves areas and volumes, and you've got to show that this contains the maximum volume or the minimum volume. Usually when it's volume, it's the maximum. And the first part of it will be getting these equations here. Right, but the way I normally teach this is if you struggle to do these optimization questions, those marks there are probably the hardest marks to pick up. You can still do the rest of the question. Like if I was to do this question, I could probably do part B1, B2 and C, 6 marks. I could probably do all of that in about a minute. Right, so if you really struggle with these, you might want to just leave this till the end of the paper. Concentrate on what you know how to do, and then come back and do the ones that you don't know how to do, or you're not so good at. All right, that's basically what I wanted to cover today. I mean, how many of you find a recording for that quite useful? I did have another poll question actually. I forgot what it was now. Oh yeah. All right. So once you leave the webinar, you'll be asked to complete a short survey, and on there, one of the questions is, would you like access to the recording of this? I just got another question for you. It should come up on your screen any second now. Would you be interested in a regular sort of webinar like this? What type of information? Anything I can help you with?